Okay, this is part 2 of a video on section 1.2, talking about absolute value. And in this video, I want to talk about writing an absolute value, a function that has an absolute value in it as a piecewise function. So let us start with C here, which is a little bit easier than D because there's only one quantity there's only one absolute value with the quantity, in this case 2 minus x in it. Okay, so we want to write our function without an absolute value. And there's going to be two pieces because depending on where inside this absolute value is positive or negative, that will determine what each piece is. So one absolute value, so this is changing signs at 2. So let's find the two pieces. So the first piece is if x is less than or equal to 2. So if I'm putting in values of x less than or equal to 2, that's actually going to result in 2 minus x being positive or 0. And so the absolute value is not doing anything there. So I have y equals 3 minus 2 minus x, or in other words, y equals x plus 1. Okay, so that's going to be one piece, and we're going to put it in formal piecewise function notation in a second, or in a minute after we finish this. If x is greater than 2, well, then that's going to result in 2 minus x being negative. So I'm going to multiply what's inside that absolute value by negative 1. So I've got y equals 3 minus x minus 2, or y equals negative x plus 5. All right, so now in piecewise function notation, I've got f of x, or my y value, my output, equaling x plus 1 when x is less than or equal to 2, and f of x equals negative x plus 5 when x is greater than 2. And so then we go to graph this, and when you graph a piecewise function, you always want to start by graphing the restriction. For both pieces, the restriction starts at 2. Even if equality is not included, always plug in the restriction first. If equality is not be included, you're going to have an open circle there, but always start with the restriction. So let's start with x less than or equal to 2. I'm on the graph x plus 1. So plugging in 2 for x, I'm going to get a y value of 3. And let's plug in one more point in this domain of x less than or equal to 2. So let's plug in 0, which will give us the y-intercept here. So when I plug in 0 for x, I get 1. And so this is going to be that left piece. And then now let's plug in 2. We're on this piece now. Let's plug in 2. And normally I'd have an open circle, but notice when I plug in 2, I'm getting 3, and that's already filled in from the other piece. So there's not going to be an open circle there. All right, now let's plug in 3. When I plug in 3, I get an output of 2. So there is my graph of this piecewise function. Okay, so now, a little bit more complicated in that you have more pieces and there's more steps, but the idea is going to be the same here for part D. So I've got two absolute values here. The first changes sign at 3/2, the second at 3. And again, I like to put this on a number line just to make sure that my cases are clear of what I can have. So let's start with the first piece would be if x is less than 3/2. So if x is less than 3/2, I've got y equals 2x minus 3 will be negative. So I'm going to multiply that by negative 1. So 1 minus 3 minus 2x. And then, but the 3 minus x, when I put in values less than 3/2, that actually is going to be positive. So I'm just going to keep it as is. So this piece ends up being y equals, 1 minus 3 plus 2x plus 3 minus x. So we've got x, the 3's cancel, so it looks like we've got x plus 1. Okay, so taking care of one piece. Next up is so I'll just write that there. If x is greater than or equal to 3/2, less than or equal to 3, then I have y equals, well, 2x minus 3. When I put in values in this interval, it will be positive. I get a positive number, so absolute value is not doing anything right here. So 1 minus 2x minus 3, and the 3 minus x will also still be positive. So that gives me 1 minus 2x plus 3 minus x, or in other words, negative 3x plus 7. Looks like that's what we've got. Okay, so the last piece is if x is greater than 3. The 2x minus 3 is still positive, so 1 minus 2x minus 3. But now, when I put in values greater than 3 into 3 minus x, like something like 4, it's going to be negative. So I've got to multiply inside that absolute value by negative 1, so plus x minus 3. So I've got 1 minus 2x plus 3 plus x minus 3, or negative x plus, okay, let's negative x plus 1. Yeah, okay. So now let's put this all into nice, neat, piecewise function notation, because Lord knows I don't want to go on a hunt to try to find the different pieces and the equations that go along with them. Okay, so f of x equals x plus 1 when x is less than 3/2. We've got negative 3x plus 7 when x is between 3/2 and 3 inclusive. And we have negative x plus 1 when x is greater than 3/2. Not greater than 3/2, sorry, greater than 3. Okay, so let's go about doing, let's see if we can, we'll just fit it in down here a little bit, do our graph. So starting with the top, I'm going to plug in the restriction, which is 3/2. So when I plug in 3/2 or 1.5, I get 5/2 or 2.5. So when I plug in 3/2, I get between 2 and 3 here. And let's, again here, since we're doing x less than 3, oh, my bad here. This should be an open circle, remember, because it doesn't include equality. And then when I put in 0, I get 1. All right, so we're going to go like that. All right, now let's put in 3/2 into negative 3x plus 7, because that will be the leftmost piece of this particular piece. So when I do that, I get negative 9/2, or negative 4.5 plus 7, which will give me 2.5, which is exactly what was the open circle before. So that's going to get filled in. And then let's put in our other extreme for this piece. If I put in 3, I get negative 9 plus 7, which is going to be negative 2. All right, so we're going into the negative range here. Whoops. So I just said 3, negative 2. All right. Makes sense. The slope is steeper here. And now the last piece. I'm starting at 3, and I notice when I put in 3, I get negative 2. It's already filled in, so I don't have to have an open circle there. So over here. And then when I put in, say, 4, another point, another x-coordinate here, I would get negative 4 plus 1, or negative 3. So putting in 4, I get negative 3. So that is my graph. And this slope should be a little bit flatter. It's hard to see here. It kind of looks like one continuous line, but shouldn't be. Okay, so those are the two examples of writing a function that has absolute value in it as a piecewise function.